All right, we're going to put our thinking caps on and see if we can interpret some rates in context. 95th installment. All righty, let's see what we got here for this stuff. Same thing, identifying factors that can affect rates, comparing rates in context, and justifying their differences. Okay, some of this stuff might make us think a little bit. The following table shows the trend in greenhouse gas emissions in Canada over a 20-year period. Okay, so from 1990 to the year 2010, 20 years. Based on the table, during which period was legislation enforced requiring reductions in the rate of emissions? Okay, well, what I want to do is for each of these intervals, for each 5-year interval, I want to look at a unit rate to make it easier to compare. Okay? So for the first one, I've got 125 minus 100, so it changed by 25 over the span of 5 years. So that's going to be 5, and it's going to be in megatons per year. I don't know if that's the correct notation for megatons, but I'm going to go with it. Mathematician, not a scientist. Okay, the next one, we've got 150 minus 125, which is another 25 divided by 5. It's a change of 25 over 5 years, which is another 5 megatons per year. So what happened is we emitted a lot more, 25 more megatons in this period than we did in in 2000 than we had done in 1995. But basically what this tells us is that our emissions are increasing by 5 megatons per year in that range. Okay, then between 2000 and 2005, we have 10 change divided by the 5 years, which is an increase of only 2 megatons per year. And then between 2005 and 2010, we went down by 10, so it's a decrease of 2 megatons per year. So I'm going to guess that it's in between here and here that the legislation was introduced, because we stopped increasing our production, or we stopped increasing the rate at which we were increasing our production and started to head toward the trend of decreasing. So I'm going to say somewhere around the year 2000 to 2005, somewhere in that range. Okay? Then it says, draw a graph that shows how over one day the outdoor temperature starts at 20 degrees, decreases at a rate of 2 degrees per hour for 5 hours. So that's our rate, 2 degrees per hour. Remains constant for 10 hours, then increases at 2 degrees per hour for 5 hours. And what's the most likely main factor causing this to happen? So we start at 20 degrees and decrease at 2 degrees per hour for 5 hours. So that's going to take us down 10 degrees overall over a 5-hour period. So it's going to look kind of, let's draw a little bit of a straighter line than that. Exactly the same degree of not so straightness. Then we stay consistent, or we've got a constant rate for 10 hours, so 5 to 15. Okay, so from 5 hours to 15. So of course we're talking time and hours on this axis. I should have done that first, eh? And on the other axis we're talking about temperature, and that's going to be in degrees Celsius. Alrighty. And then for the next 5 hours, the temperature rises at 2 degrees per hour. So we're going to go back up to where we were over those 5 hours. Okay. So notice that the rate of how fast the temperature is changing with respect to time is the slope. The negative slope going down, positive slope going up, all that stuff staying the same here. What do you think is the most likely cause? That the temperature dropped, and then for a 5-hour period, or for a 10-hour period, it stayed fairly low, and then it went back up. During a 20-hour period, which is a good portion of a day. I'm going to guess nighttime. Just a shot in the dark, but to me that sounds like the most reasonable explanation. Could have been a cold snap, could have been anything, but it says what's most likely the main factor. I'm going to guess it's nighttime. We dropped when the sun went down, stayed consistent for a while, then went back up. Okay? Alrighty. When comparing rates in context, standardize your units. Easiest to compare unit rates, of course. And notice that whenever we're comparing, The important thing is to compare them accurately, and then everything else is speculation, but do your best. All right, thanks.